Okay, we introduced this a little bit in our last lesson. This is about index rules. So indexes are powers. We've got three names for an index: index, power, and exponent. They're all the same thing. They're the number that's sitting in the air. Okay, so x cubed, this thing here is called an index, an exponent, or a power. They're all right. Okay, so don't tell your teacher that I said it was something else. I've called them index rules. Now, there are a number of rules that we have to learn to follow, but we need to understand them as well. So let's have a look at them. Well, number one says that if the base of something being multiplied is the same, then the power, whatever it happens to be, I'm going to call them letters, we just need to add those powers together. All right, so that's the rule. So let's have a look at one. If we've got b to the power of 7 times b to the power of 3, all right, I know from this that it's going to be an answer of 10. But why? That is b times b times b times b times b times b times b. Remember that a dot means times. And now we've got a times sign, so I'm going to put a times sign and another 3. But ultimately, all we've actually got here is 10 b's all multiplied together. So in fact, I've just added the powers. All right, so that is our first rule. Our second rule says that if we have them divided, I'm writing it as a fraction, but it could be written as AM divided by AN, then we subtract the bottom power from the top power. So AM minus N. Why does that happen? Let's have a look. So if I've got t to the 4 over t to the 3, all right, that's the same as having 4 t's multiplied on the top and 4 t's multiplied on the bottom. So I can cancel these. 1 for 1. What happens? I get left with 1, t1 on the top. So 4 minus 3, 4 minus 3 equals t to the power of 1. Okay? Right, next rule says if I've got something to a power and it's to another power, then that's that many times of that. So it's actually a multiplies. All right, so let's have a look at an example. P to the power of 3 to the power of 2. That says P to the power of 3 times P to the power of 3, twice. All right, so now according to our first rule, we add those powers. Those powers added together give us 6. But from here, we can see it's 3 times 2. So it's the same thing. You can work it out either way. You just need to know. This one is 2 lots of this. This one is this and this, so we add them together, multiply them together. Now, 2 little rules that we need to remember is that no matter what, if we've got a power of 0, then our answer is 1. All right? So anything to the power of 0 equals 1. Now, the reason for this is that sometimes when we get to the power of 0, if we made it 0, everything attached to that term would disappear. But it's actually only this bit that's disappearing. All right? So we've got to be very careful that we don't get rid of everything. And of course, if something doesn't have a power, then we need to remember that we've got one of them, that the power of this is 1. All right? So using these rules, just one more example here, a trickier one. If we've got something like this, all right, everything in that bracket, inside the bracket, not outside. So if there was a number out here like 2, it's not included. It's 2 of these. Everything inside the bracket is to the power of 2. So we've got 2 times, that's the 2, 5 squared, 25. A cubed times 2, A6. B squared times 2, B4. So our answer is 50, 2 times 25, A6, B4. Be careful, inside and outside the brackets.